What are you looking for in an automated 96-well Pipetter instrument system?
All of the normal things, accuracy in pipetting, ease of programming, but most importantly, reliability in operation. We must count on this instrument every day.
Reliability in operation relates directly to simplicity in design. Should you move the Pipetter head to the microplate or move the microplate to the Pipetter?
Well, that's pretty obvious. The Pipetter head has a lot of mechanism and wiring. The microplate has none. It makes more common sense to fix the Pipetter head and move the plate. However, I have more than one microplate to process.
For the basic quadra, we use a 6-station shuttle. 2 stations handle the source plate and the destination plate. Another 2 stations can handle reservoirs. That leaves another 2 stations for other accessories such as a vacuum box, ultrasonic tip wash station, and various other specialized accessories.
The 2 stations for the source and destination plate are fine for manual operation. How do I obtain more automation?
We add a pair of stackers to each side. The stackers are designed to handle anything in the microplate format, including deep well plates and reservoirs.
You mean to tell me I can move more reservoirs of liquids on and off the shuttle with stackers under program control without spillage?
Yes, I do. The stacker design uses pneumatic air cylinders. They provide a very smooth controlled action with more than adequate force. An onboard air compressor provides 30 psi.
I do not want to listen to the noise of an air compressor running all the time.
The Quadra does not use the normal rotary piston compressor. It uses a unique magnetically oscillated piston that is designed for very low noise. Its cost is higher, but you will not hear it above normal ambient conditions.
Well, I would agree pneumatics is a fine, effective way to provide and control a forceful motion. Valving can easily provide smooth motion. What is used for sensors to detect and control the motion?
Only light-actuated sensors are used. A moving flag interrupts a light beam to operate the sensor. No mechanical switches are used.
How does the Quadra load tips? When I load tips manually, it takes considerable force.
The Quadra, like most automated systems, uses an elastomeric O-ring to seal the tip to the tip pin. It takes about 1 pound of force to load a single tip.
But the Quadra is loading 96 tips at a time. That is 100 pounds of force. Where does that come from?
And now you're back to our original question. Should the Pipetter head be fixed in position or should it move to the plate? By bolting the Pipetter head to the instrument frame, it is rigidly mounted. A stepper motor-driven screw jack simply lifts the stage and the tip load jig with tips to the fixed Pipetter head. The stepper motor precisely controls the load height of the tips. A sensor on the Pipetter head signals when the tips are properly loaded to the right height, regardless of the force required. A rigid tip load jig is used that contacts each individual tip. Each of the 96 individual tips is forced onto its O-ring seal to a uniform, controlled, sealed position. Obviously, this is an important design aspect of the Quadra and its reliability.
On other flatbed pipetter systems where the pipetter head moves to the plate, how do they solve the tip loading problem?
That is a good question you should ask. For all 96 tips to work properly, each tip must be sealed to its corresponding tip pin. The simplest method is to use brute force, but the mechanism design must accommodate that. That presents a design problem if the Pipetter head must move. They have to find another way of solving the problem. It has to be solved.
You have described the vertical motion of the stage to load tips. I assume the stage is also used to lift the plate or reservoir from the shuttle to access the tips.
Yes, the height of the stage is precisely controlled by the stepper motor. This height is determined by the microplate database. The Quadra program selects the correct position for the tips within the well, such as bottom of the well, top of the well, clear height, and so forth.
How does the Quadra accommodate serial dilution applications?
In addition to the vertical Z motion that is provided by the stage stepper motor, there are two small stepper motors within the stage assembly itself. The two small steppers can precisely shift the top of the stage in both the X and Y direction. Complete serial dilutions can be made in either the 8 direction or the 12 direction. In addition, the stage can facilitate reformatting from 96 to 384 or from 96 to 48 or to 24 well applications.
What tips does the Quadra use?
The Quadra tip is a unique design. It consists of two design elements. The lower cannula holds 90 microliters. It is of suitable length to reach the bottom of deep well plates. The upper barrel holds 360 microliters, which makes the total tip volume 450 microliters. The lower cannula allows pipeline pipetting. Multiple reagents may be aspirated using air gap separation. For example, 100 microliters of buffer could be aspirated first, then a 10 microliter air gap, then 60 microliters of reagent A, another 10 microliter air gap, and 10 microliters of compound. It is fast, but more importantly, the higher volume buffer is used to wash out the lower volume critical components to improve the overall results.
Well, what about programming the Quadra?
The Quadra programming follows the same logic you would use manually. Pictorially, you load the shuttle stations with the device you want to use. This automatically brings in the device database, such as the top of the well, bottom of the well for stage positioning. Then you simply select the functions you wish to occur: load tips, aspirate, dispense, mix, wash tips, and so forth.
You mentioned wash tips. We normally change tips each time.
You can do that. It depends on your application. Obviously, it costs money and time to change tips. Tomtec has always offered ultrasonic tip washing. In all the testing we and others have conducted, we have never been able to measure carryover. All that says is if there was carryover, it was below the detection level of the measuring instrument. Two of these tests were run with mass specs at the manufacturer's own lab facility. There was no measurable carryover. Based on the experience of others, it may be cost-effective to do your own carryover evaluation. If you must guarantee no carryover, change tips.
Well, that pretty well covers the subject. Have I missed anything?
Yes, we have. The Quadra offers a unique patented design. We connect each tip and piston to a positive air supply of up to 5 psi. This is done with 96 silicon rubber tubes through a motor-driven pinch point. When the clamp is closed, it is a normal air displacement pipetter. When the pinch point opens, a surge of low air pressure is applied to the tip orifice. On a dispense, this timed dispense of air is effective in clearing the residual that is retained by capillary action. If you need accuracy at low volumes, it is a real benefit. Another important feature this function provides is true non-contact dispensing. You may dispense all but 3 microliters of your volume at the top of the well. Then, with the time dispense function, clear the last 3 microliters. This can also reduce your tip cost on certain applications.
Well, that is a unique feature.
Do you do any pipetting using organics?
Oh, yes. A significant part of our business is bioanalytical applications. We find we have to change tips when we go from organic to aqueous pipetting.
The time dispense function we have described is essential for organic and aqueous pipetting. That is why the Quadra is the dominant instrument for bioanalytical applications. When you pipette organics, you must first equilibrate the tip dead airspace with organic vapors. Otherwise, as you aspirate the organic vapors are not in equilibrium. As they evaporate into the tip dead airspace, this decreases the vacuum that is holding the column of liquid in the tip. The result is the tip drips until equilibrium is obtained. The cure is to aspirate and dispense 400 microliters of the organic first, prior to aspirating the desired volume. The problem next is aspirating aqueous after dispensing organic. The tip headspace is now full of organic vapors. As you aspirate aqueous, the organic vapors are not in equilibrium, so they condense. This adds to the negative pressure or vacuum within the tip headspace. The result is that you are aspirating more aqueous than you called for. You lose calibration. With the Quadra, we simply use the time dispense function for clearing the tip headspace of the organic vapor. The clamp opens and a burst of air pressure is used to clear the tips. 2 or 3 pulses may be required. This allows the Quadra to accurately pipette both aqueous and organics without having to change tips.
That is an important cost-effective feature.